Hey guys, Mr. Crowther here with our next unit. We are moving on to what we call sinusoidal graphs or periodic functions. So I'm going to break this into two videos so they're not going to be super long, and this is what we'll work on for the entire beginning of the unit for this first week. So our definition of a periodic function is a function that has a specific horizontal shift that results in the original function. In other words, for whatever shift we make p units right or left, that we are back to the original function. It sits upon itself. It's a repetitive function that goes in a certain period. And that period occurs in the distance of the horizontal shift. And the period will always be positive. We're going to take a look at it specifically with sine and cosine. So I want to take back to the unit circle. And if you remember some of the values based upon what theta was and measuring in radians, we can see we have a cosine coordinate and a sine coordinate. So how we're going to translate that is we're going to create a sine graph and a cosine graph. Theta will be on our x-axis. So our x-axis will be in intervals of 0, pi over 6, pi over 4, pi over 3, continued. And our y-axis will be the coordinate. So for the sine graph, it would be 0, a half, radical 2 over 2. So creating coordinates for a sine graph, 0, 0, pi over 6, 1 half, pi over 4, radical 2 over 2, and so on and so forth until we've created a full curve. And the period, based on the unit circles, one full rotation will be for 2 pi. So this is the graph of f of theta equals sine of theta. You may also see it as y equals sine of x. And again, if you look, here's pi over 6 on my unit circle. And the coordinate for pi over 6, I go back to my coordinate scale, if you haven't had it memorized, is 1 half. So on my graph at pi over 6, I'd make a point at 1 half. And then at pi over 4, radical 2 over 2. Pi over 2 would be 1. 3 pi over 4. Pi. And continuing down to the third quadrant, 3 pi over 2, back up to 2 pi. And so as this graph is being created, I'm literally connecting those points. So we have our key value in radians, but of course we can break that down further. And all of this creates a sine graph. So one full rotation goes from 0 to 2 pi. So the sine graph is this curve where half is above and half is below the x-axis. Crossing the x-axis at 0, 0, pi 0, and 2 pi 0. Cosine curve just does the same thing except with our cosine coordinates. So at an angle of 0, I have a cosine value of 1. Pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. So one full rotation from 0 to 2 pi. My cosine curve crosses the x-axis twice. And we can track it kind of like the 4 quadrants of the graph. So from here to here will be the quadrant 1. The next quarter will be quadrant 2. The next quarter will be quadrant 3. And finally, quadrant 4. We know cosine is positive in quadrant 1 and 4. We'll see that on the graph. And it's negative in 2 and 3. And you see that on the graph. So it's staying consistent with what we know about the unit circle. So the domain and range of all sine and cosine graphs without context is from negative infinity to positive infinity. And the range is from negative 1 to 1. That's based on the unit circle. So that's your y equals sine of x, y equals cosine of x graphs. And so let's talk about this graph and how it will begin repeating after 2 pi. Because of the coterminal angles having the same location on the unit circles, the x and y coordinates will be the same. So my cosine graph and sine graph will continue to be repeats every 2 pi. And we call that a period. There's one full rotation. So the periods of the sine and cosine graph are both 2 pi. So if we look at these with the domain centered at the vertical axis, kind of see the symmetry between the two. So the sine is symmetric about the origin. If you remember, that means it's an odd function. Cosine is symmetric about the y-axis, which would make it an even function. So just tying it back to odd and even functions, as those of you who are going on to calculus will need to be aware of that. So the ways the graphs can change are through our transformations. We've done transformations before: horizontal shifts, vertical stretch and shrink, horizontal stretch and shrink. The same thing happens with our sinusoidal functions, our periodic functions. They just have different names. So in order to have a vertical shift, a vertical stretch or shrink, that is called the amplitude. And the amplitude is the number that is in front of the sine equation. So our basic form is y equals sine x. As soon as I put a number in front of that, I'm changing the amplitude, and that is the distance from the x-axis to the highest and lowest point. So in this case, I have an amplitude of 3. So instead of peaking at 1, it's now going to peak at 3. Instead of being at its lowest at -1, its lowest is now -3. That's stretched by a factor of 3. And again, we say this is the amplitude. The next vocabulary term in terms of a transformation is called the midline. You'll see it's when we add something after the cosine or sine value. So this corresponds to a vertical shift. So the midline of the function is just that. When I have a graph, it is the line that goes right through the middle. If k is positive, my midline will be above the x-axis. If it's negative, it'll be below the x-axis. If there is no k value there, the midline is the x-axis. So in our basic y equals sine of x, y equals cosine of x, the midline is the x-axis. So the last thing I want to talk about in this portion of the video is the period. It is essentially your horizontal stretch and compression. It is the length of time it takes to complete one full rotation. And as you can see up here, the period can be found by the formula 2 pi over b. And b is our horizontal stretch or compression. We're going to come back to this in a second because it kind of deals with everything. But in something like this, my b value is inside the parentheses, remember? So to find the period, I'm using this 2 pi over b. B is pi over 6 in this particular equation. So I have 2 pi divided by pi over 6. So multiply by the reciprocal. The pi's will cancel out. And 2 times 6 is 12. So that means my period would be 12. So if I were to graph this function, going from 0 to 12, I have no midline, so it's the x-axis. 6 is going to be halfway. Quarter of the way would be 3. 3/4 of the way would be 9. I have an amplitude of 1 as there's no number out in front of sine. So it's going to go from 1 to -1. Sine always starts at 0, 0. Unless we have shifted it. In this case, we have not. So I'm going to peak, and then I'm going to come back down to the x-axis, and then I am going to bottom out, and then I'm going to come back up to the x-axis. So when I draw my sinusoidal curve, I have this that represents this function. Again, I'm thinking of it as quadrant 1, quadrant 2, quadrant 3, quadrant 4. So sine's positive in quadrant 1 and 2, negative in quadrant 3 and 4. And every quarter rotation, it's going to make that turn. So if you think about that cycle, that unit circle, every 90 degrees, we're changing quadrants. And this, again, this is just your introduction. We're going to go into a lot more depth as we go in the coming weeks. But we want to get you introduced to the idea of what a sinusoidal graph looks like. So this will end part 1, and I'll go on to part 2 coming up.